what I'm going to try to do today is tell you some of the things that I, not a math lead by any standard, have learned and have been able to use in marketing for actual impact. So, as a little participation exercise, how many in the room are familiar with A/B tests on Google Play? Please raise your hand. Very good. So I'm going to need your participation for this little thing. Very simple. Please raise your hand if when you see the experiment result that's going to appear, you would actually apply the new variant. So who would say the new variant is great, we should immediately apply it right now? Anyone? Yeah? This one's pretty easy. What about here? Who would apply this one? Who would say, I'm not sure, I might stick to version A? I don't see a lot of hands, so you guys seem already a bit uncertain. 1, 2, 3. Some courageous people. What about here? Google Play experiment is hard, right? So why did the difficulty increase in here? Does anyone know the explanation to why here it feels, in the last one, it feels much more difficult to even take a decision compared to the first one? That's what we're going to talk about today, so don't worry if you can't answer right now. Why I'm the one telling you about this. I've been doing ASO app growth marketing for about 8 years now. I'd rather not reflect on all those years, but essentially, among the many different cases I've had to deal with in those 8 years, there was some particular questions that kept coming back, such as, why when we do Google Play experiment, why do we keep having results that don't appear to match what we observe after we apply the winning result? So several years ago, I had a very illuminating conversation with the head of data science at my company, AppTweak, and we came up with the idea of A/B testing. Since then, Google Play made some improvements, Apple released PPO, and I learned more about statistics, so that's what I'm going to tell you about today. If you are not familiar with my company, AppTweak, you might want to hear that it's great, obviously, but also it offers a variety of tools. AppTweak has been known for years as an ASO platform. It also offers additional tools regarding Apple ads, regarding market intelligence, regarding review management. And for today, we're going to talk a bit about reporting in general, and particularly because we've recently launched a new product called incrementality. It's an incrementality calculator. It's a statistical tool. And I'll show a couple of applications. If you want to find out more, you're very welcome to visit our booth in the networking area. We have a nice part of the area with a coffee machine where there are no long lines or anything. So don't be fooled by the main tables. We have the food you need. But let's talk about why statistics matter, why we need to look at them in the first place. And usually it starts with the problem of, can you trust your own data? So in here, I have 2 conversion rates from the App Store, actually same value at the end. Who would be willing to trust the conversion rate that we see on the left? 1 install divided by 4 impressions mean 25%. Anyone willing to trust that conversion rate? Please raise your hand. Anyone willing to trust the conversion rate on the right? A lot more people, some people saying, not that sure. So the first way you can actually assess if any ratio is worth trusting would be to do what we call a sensitivity calculation. It's basically, we just say, well, if I add 1 impression, the impression is either going to deliver an install or it won't. What's going to be the change in conversion rate I will get? This applies to conversion rates in the App Store, but any ratio you have, you can do this for. That's a great way to visualize a bit how shaky the ratio you're looking at is at the moment. Main problem you get with this is that if you have an app with a fair amount of traffic, you probably get more than one impression a day. So your conversion rate is going to vary much faster. And if we say we have to add 1,000 impressions, we can look at our best and worst case scenario, but we won't have a certainty of what's the most likely situation. And so here, sensitivity is great to just quickly say it's trustworthy or it's not. It's not going to help us make much decision except saying, let's ignore this data point. And that's not what we want to do. So this is when usually we start talking about statistical significance. We talk about p-values. Who has heard of p-values before? Lots of people. Who has used p-values in the last 3 months? Oh, a couple people, interesting. I'm very interested to talk to you about that after the presentation. Essentially, p-values, we have a mathematical definition which is traumatizing to anyone who did not want to study maths like I did, which is in null hypothesis significance testing, the p-value is a probability of obtaining test results at least as extreme as the test as a result actually observed under the assumptions that the null hypothesis is correct. I have to catch my breath. It tells you how horrible this sentence is. If we put it in regular English, the null hypothesis is the idea that you would observe it's A and B are actually the same. I'm doing an AA test. So here, the p-value is going to tell us the probabilities that we would see the same change in our conversion rates, for instance, if we were doing an AA test instead of an AB test. It's going to be is this something that is a change we're observing random, or is it significant as in it should not happen if nothing actually happened? You have a math formula. Don't learn it. Or if you do, I don't know, mention it at dinner parties. It's very impressive. What's more interesting for marketers is you have a lot of online calculators, and it's so easy that you can even make your own in Google Sheets. If you want the formula, I can give it to you. I can't explain it to you, but I can give it to you. What we're going to use p-values for in marketing is essentially asking that question. Is the difference I just observed statistically significant or not? Is it just random? Does the difference in my Spider-Man make any difference to the reader? That's our situation. And so use cases that I can tell you I've used p-values with in the last 3 months include looking at different in-app events for one of my clients, trying to understand if we run a major update compared to a special event compared to something else, does that have any impact on our conversion rate? Most of the times, no. Sometimes, yes. But so we can see if certain events are actually better or not. You can use it when you look at the change in conversion rate from starting to add a custom product page to your Apple Ads campaign. Is that change significant? And if so, how can we use the information of how much the conversion rate changed to actually say, well, that helped us save X amount of money, and report that to our boss, because that's usually what makes them happy. Interestingly enough, when you also find that something is not statistically significant, it's not useless. It can be actually quite useful to know you don't have statistical significance. Recently, we had a conversation with one of our clients who was telling us about how they had a significant drop in their app average rating. And the drop correlated with a decrease in their downloads. And so naturally you'd think, well, these two are related. People will see a poor average rating and they'll say, maybe this app is not for me. What we saw is that in terms of p-value, there was a situation where we should have expected downloads to decrease because of seasonality. And the p-value that we saw told us, hey, actually, it's not statistically significant that you got a drop that was higher than expected. So it doesn't mean there was no impact, but it means that in here, the problem we had with the reviews, with the rating, was not significant enough that we could be certain this was the core of the issue, and that meant we should invest still in taking care of those ratings, but we should also look at other ways to grow the app and other ways to deal with the fact that seasonality at that moment in time is against us. We started with confidence intervals. So why do I prefer confidence intervals to p-values? It's because p-value give you a yes-no answer. They don't help you visualize the data. Confidence intervals are great to give you an error margin. I like to say confidence intervals, are a great way for cheating. It's, if you're asked, what's your conversion rate? You can give a number, and then you can be asked, well, what's your error margin? I guess I'll come up with something. The big thing, if we look at the definition is horrible. A confidence interval is an interval which is expected to typically contain the parameter being estimated. Well, that's reassuring. More specifically, given a confidence level gamma, a confidence interval is a random interval which contains the parameter being estimated gamma% of the time. Who's feeling comfortable with this kind of definition? Yeah, me neither. If I put it in English, a confidence interval is a range. It measures a parameter. So far, thank you for being so obvious. What's actually important, the confidence level is set before the parameter is found. I'm cheating. I'm not going to say I know what the answer is. I'm going to say I need to be 95% confident in my answer. So I'll give you a range instead of giving you a value. So instead of telling you my conversion rate is 20% and I need to figure out the error margin, I would tell you I'm 95% confident that my conversion rate is between 19 and 21%. Math formula looks horrible. Once again, it's not that hard. You just need to have the calculator to do it. And good news is there's a lot of calculators online you can use to do it for you. Some more things you can want to know on the theory, on the actual math of confidence interval. You have a centered interval. So when you look at Google Play results, the very center of the interval you see is the lift in conversion rate that was observed from your B variant compared to your A variant. It's also normally distributed, which means that technically it's more probable that you're going to have a result somewhere in here, right around here, than towards the edges. Now, why use p-values in your work? Why use confidence intervals, rather? Because they give you a visual representation of that error margin. You have set the confidence level before, and you just have a visual representation of how risky is it to trust the data under our eyes. As I said, you can do the math yourself. You can find online calculators. You can see that here, for my team, I actually ended up creating our own calculator specifically for App Store creative changes, because that helped me create automated observations where I can immediately say, when I compare two conversion rates from two different screenshot sets, for instance, if there is a difference, if the difference is statistically significant, if I can trust what I've seen, if it's looking rather good, very bad, rather bad, etc. There's another use case for confidence intervals, and one that I think fewer people are aware of. Since confidence intervals give you a range, they're also great to make decisions based on your worst or your best case scenario. So, are people running Apple ads in the room? A few? Okay. Here's an example of how we've used it. We have a situation where we see that today we have a bid at $1. Conversion rate from tap to install is around 20%. So we know we're going to get a cost per install like nearly at $5. And then we have the conversation with the CMO who says, I only want positive return on ad spend after a month. We know that the revenue we get from our users after 1 month is $4. So we need to make sure cost per install is below $4. If I start with the regular math, 20%, I need to reach $4 cost per install. I would decrease my bid to $0.8. Problem is, if I look at my confidence interval, and I find the conversion rate is actually between 19 and 21%, I still have a scenario in which if I bid $0.8, I can end up spending up to $4.21 if we go to the worst case of our confidence interval. So what can I do instead? I can take that information, use very basic math, and figure out that actually if I bid 0.76 instead, then I'm always going to be in my green scenario and have a happy boss. Final problem with statistics. Right now, we've only talked about comparing different moments in time, and let's see who finds this a familiar situation. You make some kind of change. You launch an ad campaign. You change your icon on the App Store. You run a new in-app event, and you see great performance. You're ready to say, we've done it. And then your CEO shows up and asks, are we sure this isn't just seasonality? That's happened to me multiple times. For this, the problem we have is, can we show incrementality? So incrementality is kind of a buzzword at the moment, but it is an actual topic that's worth investigating. The idea we have is to say, when we talk about incrementality, we want to compare not the improvement we've seen, but rather say, what is the improvement we've seen that is an improvement we wouldn't have seen if we hadn't done anything. So to do that, we essentially need to come up with what we're going to call a baseline, a counterfactual if you want to be fancy. And that's going to be the challenge for saying, we want to predict what would have happened in a regular situation and compare the actual observation to that prediction. So you can see I have mad drawing skills. But essentially, if I show it on the graph, the idea is to say, here I started doing something. Since the trend was already there, I shouldn't expect that everything would have dropped to zero. I should have expected this line over here. And so I need to take credit for this part. For this, I need to come up with a baseline. How do you come up with a baseline? Well, as you can see from the graph, AppTweak's designers have much better drawing skills than I do. But we also have data scientists who are great at figuring out what are parameters to input in your baseline. Parameters like yearly seasonality, this one is usually the one most people know about. Weekly seasonality is also important. Look at your downloads. They're probably not very stable day after day on the week. You can probably see some fluctuations. Ongoing trends. If you say, okay, I'm going to skip the problem of yearly seasonality by comparing my downloads from January of this year to January of last year, well, yeah, but if I've been growing steadily for the past 6 months because I got a new round of investment, I should probably already expect that I'm going to have a better January this year than last year. So you want to take the ongoing trends. And finally, you want to be careful about specific spikes. Because, you know, if we expect Christmas to be every day, I mean, it would be really nice, but I'm not sure everyone's budget would be able to face that. Once you have your baseline, so these are the parameters you want to your baseline to reflect, you can actually also calculate the p-value for the difference. You can calculate the confidence interval for your baseline. You can calculate the quality of baseline with additional statistics, such as the median absolute percentage error, which is something I won't get into details because honestly, this is where the math goes a bit too crazy in my opinion, but you can find these formulations easily online. What this is going to help you do is going to literally give this idea of, no, it's not just seasonality, it's actual impact from this particular thing that just happened. So that's going to be things like if your app was named App of the Day or Game of the Day on the App Store. It can be whenever you made a change on your store listing. It can be if you ran a TV campaign and you want to know if more people are searching for your brand name. It can be looking at ad campaigns, trying to understand if the ad campaign performed better than what is attributed to it, which is what people call an organic uplift, or also if actually the ad campaign is eating away some of the organic. And sure, your MMP says it got 10K installs yesterday, but if you look at the blended data, you only see an 8K install. And now you have to say, well, are we okay with that kind of cannibalization? Practical applications. We need to talk about Taylor Swift. Swiftonomics are real, guys. I'm not a huge fan at all, but when I looked at things that had actually had an impact, I found out that a few years ago, Amazon Prime Video added the Error Store to their platform. So I used our statistical calculator, and what I found out was that the day after they added the concert online, they got an increase in their revenue estimates of 22% compared to what was expected. Not seasonality, no nothing. It's really something we can tie to adding Taylor Swift on the platform. Now, all of that is things you can do in your work today, tomorrow. Some considerations, because statistics are great, but they should be wielded with caution. I have a problem personally with the idea of data-driven businesses, because to me it feels like we're saying we're letting the data make the decisions. And that's a bad idea, because we've seen already, sometimes data is unreliable. So do look at your data, but look at your data while being aware of the outcomes you are after. Here, we have very different A/B tests. The reality is any A/B test you're doing on the Play Store has 3 potential outcomes. Either you're going to get a completely negative test, either a split result, or a completely positive result. And from these, you only have one alternative. Either you keep your current screenshots or you change them. So whether we have a small increase or a massive increase, whether we can say, well, the width of the interval suggests we should still keep it running or not. That's the same picture. We're going to take the same decision at the end. So start by considering that before you go into nice statistical calculations to present to say we are absolutely confident in this, start thinking, why were you looking for that answer in the first place? What is it going to do for you? Focus on outcomes, not statistics. I told you p-values are great. You don't need to be statistically significant all the time. Take it from someone much more famous than I, who's telling you it can be really expensive to wait for statistical significance. With an example of my own, if we talk even with confidence intervals, if I tell you I have a conversion rate of 60%, but actually based on the sample size I have, I see my confidence interval 95% confidence, I'm getting between 50.4% and 69.6%. That seems like a massive difference in conversion rate. Surely I should wait before I make a decision. Actually, if I aim at $1.5 CPI and I need to update my bid is currently at 0.9 with the 60%. The variation is going to be 14 cents. That can be a lot. But if I have 1,000 taps, it's going to be 4 cents. 10,000 taps, or almost 10,000 taps, 1.5 cents. So in here, if you're willing to make bold moves, if you're saying we're okay actually cutting our bids significantly, you don't need to have massive sample sizes. You don't need to have statistical significance all the time. You need to consider what's the outcome, at what level you're actually able to start saying, okay, it's not perfect, but it's good enough for us to make a decision. And finally, learn to deal with the reality of the statistics. What I love with this example of actually our test results is essentially doesn't really matter. There's no wrong answer on this one. You could apply it. Why not? Technically, it's a very tiny bit better than it could be worse. Now, would I trust that it's going to be better? No. But if my screenshot change is something I have to do because the brand team said it's time to rebrand, I'm going to apply it anyway. It's not going to hurt me, or at least it shouldn't. It's all about figuring out if you're in a situation where the data say we're not entirely certain, are you in need of playing it safe? Because if you're the one doing the change and you get it wrong, you're going to get fired. Or are you in need of showing you're testing things even if not all of them work out? That to me is the whole part about data-powered, not data-driven. I know it might not work out. What does that mean for me? What does that mean for my outcome? In conclusion, you don't need to know the math to actually use the statistics. That one is very important to me because I'm really bad at explaining how you calculate a standard deviation, so please don't ask that question. P-values are great for yes-no answers if you want to know if the difference you just saw is significant or just random. Confidence intervals are great for visual representation. They're also great if you want to make decisions based on best or worst case scenario rather than the exact observed data. Incrementality will help you calculate the actual increment you brought, eliminate the noise from seasonality and other factors, but only assuming you can actually create a baseline that's trustworthy. And the trustworthiness of your baseline is going to be dependent on the quality of your data. And finally, statistics should inform your reporting and decision-making, but the practical outcomes are what should determine how you make your decisions. I could not talk about AI, not talk about AI. So there are a ton of online statistical calculator available out there. If you want to be conscious about the environment, please use them. But if you're ever in doubt at what the statistic was just showing you, run it by ChatGPT, because ChatGPT can also explain it to you probably much better than I just did. Thank you very much. And for those interested in the slides, we have a QR code so you can download them.